Alright, let's go ahead and give this one a go. We are going to attempt to find the solution of the following homogeneous system. Homogeneous system simply means that all of the constants that we'll see on the right-hand sides of these equations will all be zeros. Homogeneous systems are guaranteed to be either consistent or dependent. There's never a situation where it'll be inconsistent, as if you set all variables equal to 0, you're guaranteed a solution. So the system of equations is 2x1 plus 2x2 plus 4x3 minus 2x4 is equal to 0. x1 plus 2x2 plus x3 plus 2x4 is equal to 0. Negative x1 plus x2 plus 4x3 minus 2x4 is equal to 0. So the first thing we'll do is set up a 3 by 5 augmented matrix to describe this system of equations. For the first row, we'll do the coefficients 2, 2, 4, negative 2, and augment using the 0 on the right-hand side. For the second row, sounds like a mic check, 1, 2, 1, 2, followed by a 0. For the third row, we'll see negative 1, positive 1, positive 4, and negative 2, augmenting once again with 0. Now there are a number of different ways that we could obtain a 1 in the 1, 1 entry, but that is the first thing that we're going to try to get, which is a 1 in this position. Now I would say that the most straightforward way to do so would be to simply divide the first row by 2, which will work out quite conveniently due to the fact that everything in the first row is even. So we'll take half of row 1, and that'll become the new row 1. So new row 1 is going to be positive 1, positive 1, positive 2, negative 1. Second two rows will stay the same at this step. Now that I've done so, the next goal is going to be to obtain zeros in the entries right below it. So we want to get a 0 in these two entries. Now we're going to do so by using that lead 1 that we just established. So we'll take negative 1 times the first row to add to the second row. Negative row 1, add to row 2. That'll become the new row 2. And we'll simply take the first row plus the third row to get the new third row. So row 1 plus row 3, that'll be the new row 3. We'll recopy this matrix. Overall, first row is going to stay the same. 1, 1, 2, negative 1, augmented with 0. Alright, let's do this. We'll take negative 1 times 1, add to 1, that'll be 0. Negative 1 times 1, add to 2, we'll get 1. Negative 1 times 2, add to 1, we'll get negative 1. And negative 1 times 1, add to 2, we'll get 3. The augment will still be 0 because any combination of zeros being added together will still obtain 0. Then we'll take row 1 and add to the third row. So 1 plus negative 1 will give us the 0 that we wanted. 1 plus 1 will give us 2. 2 plus 4 will give us 6. And negative 1 plus negative 2 will give us negative 3. Next, we would try to obtain a 1 in the 2, 2 entry, but we actually already have a 1 in the 2, 2 entry. So we're going to use that lead 1 to get zeros in the other two positions above and below it. We can do so using the following operations. We'll take negative 1 times the second row to add to the first row. So negative 1 times the second row, add to the first row, that'll become the new first row. Then we'll take negative 2 times the second row and add to the third row to get a new third row. So negative 2 times row 2, we're going to add that to row 3 to obtain the new row 3. So overall, the second row is remaining unchanged at this step. Then we'll take negative 1 times the second row to add to the first row. So negative 1 times 0, add to 1, that'll be 1. Negative 1 times 1, add to 1, that'll give us the 0 that we wanted. Negative 1 times negative 1, add to 2, that'll give us 3. And negative 1 times 3, add to negative 1, we'll get negative 4. Next up, we'll be taking negative 2 times the second row and adding to the third row. So combination of zeros will stay 0. Then negative 2 times 1, add to 2, we will get 0. negative 2 times negative 1, add to 6, we'll get 8. Negative 2 times 3, add to negative 3, we'll get negative 9. And then we'll still have zeros for the other positions. Next up, we're going to ignore the first row, the second row, first column and second column, and obtain a 1 in this position. We'll do so in relatively straightforward fashion by taking 1/8 of the third row and making that the new third row. So 1/8 of row 3, that'll be the new row 3. So new third row will be 0, 0, 1/8 of 8 will be 1, and 1/8 of negative 9 will be negative 9/8. The other two rows will stay the same for the time being. 1, 3, 0, and then the first row 1, 0, 3, negative 4, and 0. Good. Next we'll be using this lead one that we just got to zero out the two entries that are right above it. In order to do so, we'll take the third row and add it to the second row. So row 3 added to row 2. That'll give us the new row 2. We'll also do negative 3 times the third row and add to the first row. Negative 3 times the third row, add to the first row, and that'll become the new first row. Once we do these operations, this should take us down to reduced row echelon form. Okay, so taking the third row and adding to the second row, 0 plus 0 and 0 plus 1 will be relatively straightforward. 1 plus negative 1 gives us the 0 that we were trying to get. Then negative 9/8 plus 3, that'll be 24/8 minus 9/8 to get 15/8. Then taking negative 3 times the third row and adding to the first row, the first two terms will stay the same. And negative 3 times 1, add to 3, will give us the 0 that we were trying to get. Negative 3 times negative 9/8 will be positive 27/8. We'll be adding that to negative 32/8. Negative 32 and positive 27 will give us negative 5/8. And of course, 0 stays 0. Now with this in mind, let's go ahead and reinterpret these. We have x1 minus 5/8 x4 is equal to 0. x2 plus 15/8 x4 is going to be equal to 0. And x3 minus 9/8 x4 is going to be equal to 0. We can see from these equations that x1, x2, and x3 are all lead variables, which means that x4 is going to wind up being a free variable. So we'll say let x4 be equal to t. If you wanted to go for a slightly more advanced technique, you could also refer to it as 8t to get rid of the fractions. Solving these equations in terms of t will now give us x1 is equal to 5/8 t, x2 will be equal to negative 15/8 t, and x3 will be equal to positive 9/8 t. So the solution set is going to be the set of all ordered quadruples, I guess, of the form 5/8 t, negative 15/8 t, 9/8 t, and t, where t is an element of the set of real numbers. That is the solution of our homogeneous system.